Here you're asked to find the change in the kinetic energy of a car with mass 810 kilograms, which goes from 0 speed to 30 meters per second. First, let's note down the formula for kinetic energy, which is half mv squared. Using this formula, we can find the kinetic energy that the car has when it's traveling at 30 meters per second, and we can call that the final kinetic energy. It will be half times the mass of the car, which is 810, times the square of the speed of the car. This gives 3.645 times 10 to the power of 5 joules. We can find the initial kinetic energy. Similarly, the mass is the same, but this time the car was not moving, so the kinetic energy is 0. This gives the change in kinetic energy, which is the final minus the initial kinetic energy, giving the answer as 3.645 times 10 to the power 5 joules. Next, you are asked to find the average power generated by the car engine, with the assumption that all the power generated is used to increase the kinetic energy of the car. We can note down the formula for power, which is change in energy divided by change in time. And this is where the assumption becomes useful, because we already found the change in kinetic energy of the car. Based on this assumption, we can say that this energy is going to be equal to the change in energy for finding the power. So we can write 3.645 times 10 to the 5 divided by 12 seconds, which is the time it takes for the car to go from 0 to 30 meters per second. And this will give the power of the engine, which is 3.04 times 10 to the 4 watts. In this part, you are given the efficiency of the car, which is 25%. Let's remember that efficiency is equal to useful output divided by the total input. This will be useful for the next part of the question. You are also given the capacity of the tank and the energy that each kilogram of petrol provides. There's a constant resistive force of 500 newtons at the current speed of the car, which is 30 meters per second. In the first part, you need to calculate the work done against the drag force in 1 second, which this can be recognized as power, since the power is equal to energy transferred or work done divided by time. We can then use the formula for power, which includes force and speed, because they are the two quantities that we know. Putting in the values into the formula P equals FV, we have 500 times 30, which will be 15000. Units will be joules per second. For this part, we need to find the distance that can be traveled when the tank of the car is full. The speed does not change and stays at 30 meters per second. To answer this question, let's first find the energy from a full petrol tank. We know we have got 18 kilograms, and each kilogram provides 46 megajoules, and I need to times it by 10 to the power of 6 because of the mega, and this is going to give 8.28 times 10 to the power of 8 joules. So this is the energy available from the petrol in the tank. But the car cannot use all this energy. Looking at the efficiency formula, which says that useful output, if we cross multiply, will be equal to the efficiency times total input. And we know that our efficiency is 0.25. Multiplying this by the input, which will be the input from the fuel, 8.28 times 10 to the 8, and this gives us an output energy of 2.07 times 10 to the 8 joules. This is the energy that will be useful to the car. We can then find how long this energy will last for the car. From the previous part, we know that the car is doing work at this rate. It's using 15,000 joules each second. Using this information, we can write that the drive time is going to be the energy available divided by the energy used in each second. And this will give 1.38 times 10 to the 4 seconds. We can then find the distance, which will be equal to speed times time, and we know that the speed is 30 meters per second. So if we do 30 times 1.38 times 10 to the 4, this will give us 4.1 times 10 to the 5 meters.